Sino to? Okay, so I will start my screen sharing. Anyway, this lesson is very easy for you. And you have encountered this already. Do you have your periodic tables with you?
Yes po.
Yeah, sige, sige. Okay. Okay, class. So this lesson is about the atomic theory that you are familiar with. Okay. So for this atomic theory, we will just discuss about the subatomic particles. Okay. So you please have your periodic tables ready with you. And so you are going to be able to recognize the properties of the elements within the periodic table based on their location. And then you're going to differentiate the significance of electronic configuration as a basis for their classification. Because here, class, we will be able to do the, pasukin mo natin si Ortesa, the electronic configurations of the elements, and by looking at the electronic configuration we would be able to know its properties. Okay. Honest Christian. Okay. So here in the atomic theory, you already know that compounds are made up of elements. That's why you have your periodic table. And also the elements, they are composed of atoms, and it came from the Greek word atomos, and it's not attributed from Plato or any other philosopher. It is attributed to Democritus because atomos means indivisible. So in atoms, there are three subatomic particles. As you recall, they are the protons, neutrons, and electrons. Protons, which is positively charged, electrons, which is negatively charged, and neutrons that are neutral. And in a stable atom, it should be that your number of protons and electrons will be equal for those that are in the neutral state. Okay. So according to John Dalton, in a chemical reaction, like when you form your compounds, there will just be a rearrangement of atoms. And the atoms are not diminished when they form the compounds. So this atomic theory follows the law of conservation of mass, which means ideally, theoretically, your masses of your reactants would be equal to the mass of your products for theory, but in actual class, there are still losses. So what we follow when we do electronic configuration will be the atomic model of Niels Bohr. So from Niels Bohr, it is the planetary model where your nucleus, which is composed of neutrons and protons, are being surrounded by electrons that are in orbits. And electrons are fast-moving subatomic particles. And because your nucleus is composed of neutrons and protons, it is the reason why the atomic mass that are indicated in your periodic table of elements are based on the mass of the nucleus. And as you can see, for an atom to be neutral, as I have mentioned, your number of protons should be equal with your number of electrons. Okay, papasukin muna natin si classmate ninyo. So in your periodic table, the mass is there, even if in the midterm we will be using it as grams per mole. Those that are indicated in your periodic table are expressed as atomic mass unit, which is equivalent to 1 over 12 the mass of carbon. Before class, the basis of the atomic masses was relative to oxygen. But there were some scientists who discovered that carbon is more stable compared with oxygen. That's why now they refer those that are in your periodic table are based on the most stable isotope of carbon. The masses are relative to carbon. Here in the periodic table, as I have mentioned, the atomic weight, they are dependent on the weighted relative to carbon, they are the weighted average mass of the isotopes of an element in atomic mass units. So when you say isotopes class, we refer to the same element but the same atomic number although they have different mass numbers. So what does it mean by different mass numbers? It means there are different number of neutrons in the nucleus. So they get the average masses of those isotopes, then that will be the ones that will be indicated in your periodic table. Then also, for those that have isotopes that are very unstable, they get the mass of the most stable isotope that is available. So there is a convention when you write your elements indicating the atomic number and the mass number. So here, your X will be the element symbol. Then your A will be your mass number. So the mass number is the rounded off atomic weight. So again, the mass numbers that you can see in your periodic table, the atomic masses dependent on the nucleus, and it is for that reason why your mass number is equivalent to the sum of your protons and your neutrons. And as I have mentioned before, if your protons will be equivalent to your neutrons, it should also be equivalent to your atomic number. That's why it is equivalent to Z plus neutrons. Because the Z is equivalent to your atomic number, which is also equivalent to your protons and your electrons. Yan. Okay. Wait. Na muna natin. Bubunot muna ako. Sige. Give me the atomic number and sino yun? Okay. Give me the atomic number and atomic weights that are indicated in your periodic table, Mr. or Miss. Dali, bunot. Dali. Kan. Ano ba to? Babae ba to? Lalaki? Kan, are you still there? Mr.
Opo, ma'am.
Kan? Ayan. What is the atomic number and atomic weight of carbon in your periodic table?
Atomic number, ma'am, 6.
Hmm?
Tapos, atomic weight, 12. 12.01.
01. Isa lang ang naka-indicate sa periodic table mo?
Opo, ma'am.
Isa lang. O sige. Ganito class ha. Whatever is written in your periodic table, you indicate it in your solutions. Okay? Ayan. Sige. Thank you, Mr. Kan. Kasi there are some that have 2 atomic masses for carbon. So if that is the case in your periodic table, you choose the heavier one. Okay? So then, give me the atomic. Pasukin muna natin si Acebo. Give me the atomic mass and atomic number of Monokai. Are you there, Miss Monokai? Wala si Monokai? Sige, muna tayo iba. Meron na to eh. Mr. or Miss Litan. Are you there? Litan? Ayun, Mr. Lalaki. Mr. Litan, give me the atomic number and atomic mass of uranium. 92. Oo, and then ano pa yung isa? O isa lang nakasulat sa iyo? Isa. Isa lang, okay. So, ibig sabihin, di ba naka-bracket siya? So, it means when it is in a bracket, it means it is the most stable isotope that they considered in the atomic mass. Okay? Ayan, sige. Thank you, Mr. Litan. Sulat natin dito. So, class, the elements that we have mentioned, that your classmates have mentioned, have different isotopes. Like, for example, for carbon, there are 3 isotopes for carbon. So, as you can see here, all of them have atomic masses. All of them have atomic numbers of 6, but their mass numbers are 12, 13, and 14. Then, the same way, for uranium that was mentioned by Mr. Litan, you have uranium. Both of them have 92 as their atomic numbers, but their sino yun? But their masses are 235 and 238. And also, for hydrogen, yan. So we have 3 isotopes for hydrogen. So hydrogen 1, 2, and 3, although all of them have atomic numbers of 1. Then also, aside from the X, A, Z notation that we put, you can also write it based on the mass number. Like for carbon, it can be written as carbon 12, 13, and 14. So it means here you are referring to the isotope that has a mass number of 12 for carbon 12, then carbon 13, carbon 14. The numbers that are beside them are their mass numbers, although they all have atomic numbers that are 6. The same for uranium 235 and 238. You refer to the mass number as 235 or 238. And the same for hydrogen. So why do we write it this way, where we put the mass number and the atomic number? Because we would be using them in solving for the number of the subatomic particles, as we will do now. Okay? Talaga, pumalakpak na naman. Okay. So, for your example here, how many protons, neutrons, and electrons are contained in an atom of argon with an atomic number of 18 and mass number of 40? So, if you will look at argon in your periodic table natin. Sige. Mr. Adriatico, what's the atomic number in your periodic table for argon? Andito ba si Mr. Adriatico? O, nawala. Si... Ma'am, wait lang po. O, sige, pinaglaban ni Adriatico. Sige. Tinaw mo na yung atomic number ni argon. Si Mr. Adriatico, nawala. Muna tayo, iba. O, nawala si Mr. Adriatico. Lesol. Andito ba si Ma'am, try ko po si Ortesa. O, nanigurado na
Yes.
si Ortesa. O, sige. Or,
Hello po.
si Lesol. Andito pala si Lesol eh. O, Mr. Lesol, what's the atomic number of argon?
Atomic number of argon is 18.
Then atomic mass?
Atomic mass is 39.95 or
Ay,
40.
okay, sige. So, it's 39.95. So, as you can see, class, it is 39.95 yung kanyang atomic mass. So, as I have mentioned before, we round it off to make it as a mass number. That's why the mass number here is 40. So you first write it, for it will be easier for you to recognize by writing it in the XAZ notation. So the symbol with the mass number and the atomic number. Then you are required for the subatomic particles. Number of the subatomic particles, protons, neutrons, and electrons. And then your equation, as what was shown in the formulas before, your atomic number is equivalent to your number of protons and number of electrons in atoms that are in the neutral state. So based on the notation, you can easily see that your number of protons are 18 and the number of your electrons is 18 also. Then, if we are going to solve for the number of neutrons, we will have to derive an equation. Yan. So we already have solved for the protons and electrons. If you recall, the mass number is equivalent to the rounded off atomic mass. So that is equivalent to the mass of the nucleus, which is composed of your protons and your neutrons. So we express it this way, where your mass number equals protons plus neutrons. Then we will derive an equation by transposing your number of protons for us to derive an equation to solve for your number of neutrons. And your number of neutrons will be equivalent to the mass number minus the number of your protons. Then you just subtract and we will get your number of neutrons, which is 22. So we do another example. Ayan. Okay. So this second example, you are going to determine the number of neutrons in carbon 14. So if you recall a while ago, we have the isotopes. So this time, the given in your example is the isotope of carbon that has a mass number of 14. Then we should first write it in the XAZ notation. So as you can see here, mass number is 14 but the atomic number is still 6 for carbon. You are being asked to solve for the number of neutrons. So again, we derive the equation. Your mass number equals the sum of your protons and your neutrons. By transposing to the other side, we will derive the equation for your number of neutrons, which is equivalent to your mass number minus your number of protons. So it will be 14 minus 6 and your number of neutrons is 8. That is because we have considered the given which is carbon 14. But of course, if the given is carbon 12, so your number of neutrons will be different also. Okay. So what we will do next is the electronic configuration. So why is it that we consider the electron configuration? That is because class, when you form your compounds, the valence electrons of your elements, your cations and your anions, they are either transferred or shared to form your compounds. That's why those electron configuration indicate the valence electrons, which are the electrons that have the tendency to be shared or to be given or to be accepted. So in the atomic number, as we have mentioned, it is equivalent to the number of electrons because in an electron configuration, the sum of the electrons are equivalent to, sino yun? Pasukan mo natin. So in an electron configuration class, the sum of the electrons in your electronic configuration is equivalent to the atomic number. So that's how you will know that you got the electron configuration correctly. And there are three ways to write your electron configuration. So if you would look class and you recall when you were in high school, it was KLM. So based on the energy level, it's also referred to as shell. And For each shell or energy level, it contains your electrons. So please look at your periodic table, class. In other periodic tables, they have it on the lower left side. Okay. Then the bigger periodic tables, they have it also on the upper part in the middle portion. So you can see there the electron distribution mnemonic. So this electron distribution mnemonic, you are not required to memorize because you are allowed during your exam and even in your exercises to use your periodic table of elements. So here in the electron distribution mnemonic, it already represents the first way of expressing your electron configuration, which is the unabbreviated form. So if you will look at the electron distribution mnemonic, it contains your SPDF. These SPDF are your subshells or your orbitals within your KLMN or your energy levels. When you were in high school, it was KLMN. But here in college, we refer to them as your N or your energy level. And your SPDF are your subshells within your energy level. So if you will look, please look at your periodic table. In your electron distribution mnemonic, so that is 1s, 2s, 2p, 3s, 3p, 4s, 3d. So please take note, it should be 4s first before your 3d, as you can see in your electron distribution mnemonic. So the reason for that, we follow what is in your mnemonic. That is because it is easier to fill out the number of electrons within the S subshell compared with your D subshell. So as you can see in your periodic table, please give us the maximum number of the electrons that can be contained within the SPDF subshell, Mr. or Miss. Hipolito, are you here? Babae yata to. Kanina may nakita akong Arlise. Mr. or Miss Hipolito?
Yes po, ma'am.
Yes. What are the maximum number of electrons within the SPDF? You can see it in the electron distribution mnemonic.
Saan po yun, ma'am?
Electron distribution mnemonic in your periodic table.
Wala po kasi sa periodic table ko na ganun.
Kahit do sa baba,
Opo.
sa lower left, paano ka
Wala
mag-aano?
po.
Paano? Sige. Si ano na tawag na tayo sa iba. Si Mr. or Miss. Andito kaya to. Guda, are you here?
Yes po, ma'am.
Ayan. Ayun, si Guda. Mr. Guda, in your electron distribution mnemonic, what are the maximum number of electrons that can be contained within the SPDF?
Maximum number.
Yes, sa note. Note ng inyong periodic electron distribution mnemonic.
Parang kulang po sa akin ata, ma'am.
Wala yung sa SPDF?
Opo, ma'am. Di ko
Pero-
po makita.
Wala kang electron distribution mnemonic?
Di po kita, ma'am eh.
Maliit
Parang
yung
di po
periodo.
ata updated, ma'am.
Ay, ibig sabihin wala sila Tennyson at Oganison dyan. Yan, munot. Wait lang. Hindi ko alam kung Mr. or Miss to. Digang, are you there? Si Digang ba na andito? Hindi na nagsalita, parang wala. Mhm. Meron na tong ano eh, recitation eh. Si ano, Sorne. Are you there, Mr. or Miss Sorne? Ma'am, di ko po makita. Hindi raw makita ni Digang. Miss Sorne, what are the maximum number in the SPDF in your electron distribution mnemonic? You can see it in the note sa electron distribution mnemonic. For S, how many electrons? Yun. O, di ba? Meron siya eh. So, please take note at what Miss Sorne have indicated. So, for S, it is less than or equal to 2 electrons for the S subshell. Then for P, it is less than or equal to 6. D less than or equal to 10, and F less than or equal to 14. So it means the maximum for S is 2, for P is 6, for D is 10, and for F is 14. Okay? Ito, dali. Yan. So we will be using those and we will be observing them. So why is it that you have to consider the SPDF? Because class, in your periodic table, their arrangement there are already based on the block which will be filled up in their subshell. As you can see, groups 1A and 2A are the S block. Then those that are transition metals are the D block, those that are in yellow. Then groups 3A until 8A are your P block, and your lanthanide and actinide series in the bottom part are your F block elements, the lanthanide and actinide series. So in your periodic table, aside from the unabbreviated electron configuration, we also use the noble gas notation. O class ha? So in the noble gas notation, please take note that you are going to use the noble gas one series or period above the element being asked. Okay? So for example, class, if you will be asked to write the noble gas notation of potassium, as you can see within period 4, it has krypton as its noble gas, but you will not be using that because krypton has a higher atomic number compared with potassium. So what you will be using, as what is mentioned there, you should use one series or period above. So you should use argon. Then if ever you will be asked to write the noble gas notation of barium, as you can see in period 6, radon is the noble gas along period 6. But you will not use radon because it has a higher atomic number compared with your barium. What you will be using will be xenon. So also, if you will look at your periodic table, there is already the noble gas notation within each element. But you are not going to follow that because if you will look at the noble gas notation within each element, they do not follow the electron distribution mnemonic. So please take note that you should not copy what is written as the noble gas notation in your periodic table because those that are indicated in your periodic table as the noble gas notation are in the excited state. So if you will copy that, you will have a wrong answer if you will be asked for the number of valence electrons and the number of electrons in each orbital. That's why you should still follow the noble gas notation, which is equivalent to the electron distribution or an abbreviated electron configuration. Anyway, we have examples later. So the next class, the easiest way of expressing electron structure is the Lewis electron dot symbol. So Carl Lewis class, he is one of those who differentiated acids from bases. According to Carl Lewis, acids are electron pair acceptors while bases are electron pair donors. So it has a different approach compared with Sivante Arrhenius, who differentiated acids and bases as acids as proton donors and bases as proton acceptors. For Carl Lewis, he based it on the electron pair. So it is from him also that he devised this electron dot symbol. So in the electron dot symbol class, the number of valence electrons are indicated around the element's symbol. As you can see, what is being shown there for carbon. So there are four dots. It means carbon has four valence electrons in its outermost shell. Okay. So we will have the examples now. Okay. So for the first example, this is sodium that has an atomic number of 11. So we no longer write the mass number because again, electrons should be equal with your atomic number and your protons. That's why we just write the atomic number. So the first one, you are being asked to write the unabbreviated electronic configuration. So it will be this one, 1s2, 2s2, 2p6, 3s1. And if you will look, all the exponents in each of the subshells are already your number of electrons. And if you will add your 2 plus 2 plus 6 plus 1, it will be equivalent to 11. So this number of electrons is equivalent to your atomic number for sodium. Then the next that you would be writing will be the noble gas notation. If you will look at your periodic table, for period 3, your sodium, along sodium's line, the noble gas there is argon. You're not going to use argon because argon has a higher atomic number compared with your sodium. So what you will be using will be the noble gas one period above, which is neon. So neon 3s1. Why is it that it is only 3s1? Because your neon already represents this unabbreviated part. The atomic number of neon, which is 10, is equivalent to this in your unabbreviated EC. Then, if you will be asked to write the Lewis electron dot, you can look either in the unabbreviated electron configuration or the noble gas notation. So it is 1. So you just put 1 dot. Then another property that you can see in your electron configuration is your number of valence electrons, as you can see, and your energy level. So energy level N, you refer to the highest number within your unabbreviated EC. So it will be energy level 3. Okay. We have another example. Okay. So this time we use iron. So iron has an atomic number of 26. So for the unabbreviated electron configuration, it will be this. Okay. So if you will look, you add all the number of electrons, it should be equivalent to 26. Okay. Then, if we are going to look in the periodic table, your iron, which is in period 4, has krypton as its noble gas along period 4. You are not going to use krypton because krypton has a higher atomic number compared with iron. That's why what you will use for your noble gas notation will be argon, because argon having a lower atomic number already represents this part of your unabbreviated electron configuration. Then you write for S2 3d6. Again, please take note, you don't put it as 3d6 for S2 as what is indicated in your periodic table. It's not that. It should be 4s2 3d6. 4s should come first before your 3d, because based on your electron distribution mnemonic, it is easier to fill out 2 electrons within the s subshell compared with 6 electrons in your d subshell. That's why 4s2 comes before 3d6. Then in your Lewis electron dot symbol, you will have to look at the highest energy level and the electrons that are contained there. So as you can see, for iron, we look at the highest energy level, which is 4. It contains S2 for S2. So there are 2 electrons. So there will be 2 dots in your Lewis electron dot symbol. Then again, when you have done this, you can already identify how many your valence electrons are. So it is 2, and your highest energy level will be 4. So another example that you have to take note, class, ha? So this one we will use gallium, which is a liquid metal. So your gallium has an atomic number of 31. So in its unabbreviated electron configuration, it has this. Okay? So if you will look and add again, the electrons in your unabbreviated electron configuration should have a sum of 31 for it to be equivalent to your atomic number. The electrons in a stable state should be equivalent to your atomic number. So it should have a sum of 31. Then, if you will look at your periodic table, class, for your gallium, along period 4, krypton is the noble gas within period 4. But again, you're not going to use krypton because krypton has a higher atomic number compared with your gallium. So you will be using in your noble gas notation, 1 period above it will be argon. Then 4s2, 3d6, 4p1. I have already explained to you why 4s2 comes before 3d6, because it's easier to fill out the S subshell compared with your D subshell. And it is argon because argon represents this part of your unabbreviated electron configuration. Then By looking at your energy levels, we would be able to identify the number of valence electrons. For gallium, it will be the sum of the electrons that are in the fourth energy level. So it will be 2 plus 1. There will be 3 valence electrons for gallium. So you put 3 dots in your Lewis electron dot symbol. And from this, you would be able to write the number of valence electrons, which is 3, and your energy level. Again, as I have mentioned, you look for the highest number within your unabbreviated electron configuration. The energy level will be 4. Okay. Okay, so I will upload class your prelim exercises 5 and 6. There are some of you that I asked for their solutions. Class, always write your solutions in all your exercises and even in your exam, even if you use your calculators, because we should be able to see how you arrived at your answer. Okay. At naman lumabas ng aking meet na to. And also, I will upload your module 3. And don't forget to write your signature over your printed name in your honesty clause. Okay?